It appears to me it was in there because it got smashed. Took a while, Hello everyone, welcome back to Center Stand Mechanics. My name is Kyle, and today I'm going to be going through the wiring on this 1975 Honda XL250. This one is based on a 6-volt system. I'm mostly familiar with 12 volt. They kind of phased a lot of the 6 volts out in the 70s, and everything switched over to 12 volt from there on out, and so that's I'm more familiar with that, but it's basically the same sort of thing. It's just less voltage. It just means that you need different light bulbs and different components. There's some different things about these bikes that you don't see on modern bikes, but I'm gonna try to explain the electrical specifically on the 75 Honda XL250, and there's definitely similarities, cross brands and cross models, and they all kind of follow a similar train of thought, I guess you could say. A lot of you guys out there, probably this is gonna seem pretty basic stuff, but for those of you that are kind of new to working on bikes and stuff, and are a little bit confused about the wiring on systems on these bikes, like, I get it. They are confused. It's taken me a while to figure this one out. I kind of had to do it bit by bit. I have a little wiring diagram here, and I'll probably explain that in a bit later. And yeah, and just go through what I've kind of figured out with this bike, some things that I found, and so on. So, yeah, so let's get started. Okay, I've got everything kind of apart. Got tank off, the seat up, and I got the headlight out, and I've just been going through and just making sure I've got all my connections right. And I was gonna kind of explain how some of this works out, but one of the very first things I discovered with this bike, when I started playing around with it, with the electrical. Now, if you're new to working on bikes or engines or cars in particular, this is a good little demonstration. So I got myself here. I got a 6-volt battery, and I went to hook it up. And so when I make this is the negative side. They already got the positive hooked up. But when I hook this up, if you look closely at it, there's a little spark. You hear that? You can even see it kind of smoking a bit. But let's see if you can see that. Yeah, see the little spark there? So whenever you see that, whenever you want to watch for this every time you hook a battery up to anything like a car, motorcycle, or whatever, and you don't want to see a spark when you hook the battery up. Now, that being said, there are things in vehicles. You might have like something that's drawing power, like a stereo that's holding memory, or something in the system that has like a capacitor or something that's charging up. Like, so you might see an initial spark, but then once it's filled up, you shouldn't see any sparks afterwards. Like, so keep that in mind also. But generally, you don't want to see a spark. And if you do see a little spark, I check, make sure, the key's off, nothing's on, right? None of the brake levers are pressed, like, looking around for what could possibly be on, because that's telling me it's drawing power somewhere. And if there's nothing on, and I can't see where the power's coming from or where it's being drawn from, it's telling me I got a problem, which is what I got. There's a problem with that. It means I got a short somewhere in the system. There's a short, so you want to watch for that. And again, another pro tip is always hook up the positive first. You know, most of you already know this, but if you're new, you know, when you're putting in the battery, hook up positive, then you want to hook up your negative. You're taking the battery out, take the negative off, and then the positive. You do it in that order, just for safety. Like if you got a wrench on here and the positive's already hooked up and you put the wrench on, nothing's gonna, you know, short out. But if you already hooked the negative up and you're wrenching to this one, well, now you got a circuit, you make contact with the frame somewhere, it'll spark. And that's the whole reason for that. And if you got some kind of a fuel leak, you know, trust me, these bikes, you'll have fuel leaks whenever you're working on this stuff, and you make some kind of connection like this right next to the carburetor, boom, and this thing will light up. Like I'm telling you, with fuel, sparks, it's a bad combination. So just be safe out there. Okay, so basically I have some kind of a short. Now off camera I was playing around with this and I figured out where the problem is, but I'm going to kind of show you how I figured it out fairly quickly. But you know, so this could be a short anywhere. I might have a wire touching the frame somewhere, and you know, it could be a nightmare to find. Like you really don't want to be finding that, but if you do, you have to figure it out, because you got a dead short. You're going to have a dead battery in no time. You may, you know, you might even have a fire, right? So you really got to figure this stuff out. So I'm going to get my multimeter and I'll show you how I figured this out. So most of these multimeters have a function where you can check continuity and there'll be a beep. So it's this one's marked with a little, looks like a little, you know, sound speaker or something, and I put it on that one. It's and then so whenever you get a connection, you hear that beep, right? So you can go around and check things like fuses and whatnot with that. So what I want, so I got to figure out where this is coming from. So for instance, you know, you want to check your ground. This is my ground, and then you want to make sure you got ground. You can go around and touch anywhere on the bike, and you can see that I have ground, you know, to the engine, you know, anywhere, you know, all over the place, right? So now if you disconnect the battery completely, and then if I put this in the positive thing, now there should be no connection to ground from the positive side, but when I touch the frame, I got continuity. So somewhere from the positive side of the system, it's making contact to ground, and that's, you don't want that, guys. It's bad for business. So you got a problem. So then the next thing I did is, so here's the fuse. This is this bike only has one fuse. It's kind of simple, but so here's the main fuse. So basically power's coming out of the battery and coming up here, and then this is the first spot where it's going to break. So you can check between here and here. See, we got continuity, right? So we can check here to the frame. So we got continuity. So now this is the other side. So this goes throughout the whole rest of the system, right? This is directly, so I'm starting to think that my problem's from here to here now. And so if I go hook one of these probes up to here, see, look, no continuity. But if I go from here to here, I got continuity. So that means from here, somewhere, this wire only goes from here to here. But then there's also this other wire connected to it. Now where does this go? You go, okay, well it goes down into here. It goes into this little unit. Okay, well let's see what happens if So I unplug it. So we go back to here. Nothing. Right? So we'll check the continuity. So that, yeah, that's going through. Nothing. So there's something going on when I plug this back in, I've got the problem again. Right? Yeah, so there's something going on. What is this thing? So I went and unplugged this again. And what is this? Oh, what do we have here? So I've already had this off. I'm trying to pretend like I don't know what I'm doing, or I haven't seen this before. But so what we got here is the rectifier. So some of you guys are probably familiar with rectifiers. The modern ones that you see typically every day now are what's called a voltage / rectifier. Like they do, it's kind of doing two things. The rectifier takes AC power and converts it to DC, and then in this system it has another unit that's called the regulator, which is located up under here. Where is it? So it's right here, in behind the coil. So it's got a separate voltage regulator over here. So this is just a rectifier on this particular model. You don't see this type of thing much anymore. And this is a 6-volt rectifier. And so here you got your 2 phase wires. You've got a ground, and then they got the positive going to the battery. Okay, so, and that's where, so what we got here, so I'll take this out and I'll just test it. So we go positive to negative. Well, see, we got a fault. There's a ground fault right there. And all the phase wires. Let's see, let's check the phase wires. Yeah. Now, I discovered this a while ago, and I ordered another one, and I'll just show you the difference on the bench from a faulty one to a good one. So this here is the same thing. This is sort of like a cheap one off of Amazon, and it's apparently does the same thing. So it's even got the same plug and everything. So it's supposed to be a direct replacement for this 6-volt rectifier on the Honda XL250. So again, so the green wire is ground, and it's showing a fault there. And then, so we'll go to green wire to the red one. See, no fault. Okay, and that's the way it's supposed to be. So if I plug this one in, I won't have that ground fault anymore. So this one's faulty, and then there's other things you can check. I had to switch functions here. So now you see this, you want the one that has the I think this is the diode. I'm not like I say, I'm not an expert at this, but you want the one that has the arrow like that. And then if you put the positive on the negative, you can check your phase wires, right? And you get a reading like this, like 0.557. We'll check the other one, 0.573. So pretty consistent. And then if we go over to this one, we'll put the red one on the green, and then go to the yellow. So we get a reading of 5.8, so very similar. And that one's 0. So you see that? So I think that's where the fault is on this one on the pink wire. So that one's good. So the yellow phase wire is good. The pink one is bad. It's not showing any reading. So I'm not exactly sure what's happening here, but I think it's not allowing power to pass through it. Yeah, I'm just going to take this bracket off the bad one and put it on the new one. And I'll probably use that bolt too. Make sure that's on there straight. Yeah, so I got the bracket on there, and then I'll go put it in the bike and plug it in, and we'll see if we still have that short. Alright, so this little guy lives up in here. So there's a little tab right here, and if you look closely, there's a hole right here in the frame. So that goes up and rests up in that little spot there. And let's see if we can't get that on. See, like so, and if you look, there's that little tang right there. So that holds it in securely so it can't twist around in there. So that's secure. And then I'll just have a look. Find the lead for it. There it is. And I'll just plug it in. Make sure the wires, the green and the positive, are the same. This should just push right down in there. There, like so. There. Okay, so now if I hook this back up, hook up the positive first, and then when I go to hook up the negative, there shouldn't be a spark. See? No more spark. So now I can hook that up. I'm going to clean these wires up and, you know, place them in there better when I get done with it. So now the battery's hooked up. So now I can turn it on without that problem. And, you know, we got a neutral light. Everything off, on. Okay. Now, and then here's something you don't see every day. So this button right here, not the kill switch, but this is off, on. So what this does is you turn it on, that turns on all your lights. So you got your backlighting for the gauges. It turns off the tail light, and it turns off the headlight, and probably the brake lights too. Let me see. Yeah, no, you still have brake lights, but you don't have the tail light. And I wasn't sure what the switch is for, because you don't see that very often anymore. So, and I think the reason behind this switch, so because this is a kickstart only, and sometimes it's probably hard to start, and you want to divert all the power from the system, so when you're kicking it over, the lights aren't robbing the power out of the system. So you can turn the lights off, kick it over, get it started, get it warmed up and running, and then you can turn the lights on. And I think that's pretty much the whole reason behind it. It's just, you know, so you can start it a little easier without having all the lights running. If I'm wrong about that, you know, let me know, but I think that's the whole purpose behind that switch. So, and I'll explain kind of what's going on with the switch, also like what it's actually turning on and off. It's kind of a two-way, it's a kind of a two-in-one switch. It's one half of it is DC power going to all the running lights, and the other half is AC. It's turning power on, AC power to the headlight. So it's kind of doing two things at once. So you're cutting, when you turn it off, you're cutting the DC power to the whole running lights, and then you're also cutting AC power to the headlight when you turn it off. But we'll get into that in a minute. I just wanted to, you know, I just want to show you there's something wrong with this this flasher unit here. So depending on how you hold it, so you can see how, if I can get the lights to flash if I push on this. So I need a new flasher. There's something wrong with this one, but you can see I got the dash light working, and I got the back one working. And then if I change it to that side, the right side, and yeah, so once I get a new flasher, this should work, which is pretty cool. I had to get new signal light lenses. That's one of the things that came in the mail. These signal lights, the lenses, you can still get from Honda. There's a few things that I got from Honda that I was surprised. I got a new brake lever, which is OEM Honda, and I got new signal light lenses, and you can also get the OEM handlebar grips too. So I got them in a box. I'll be putting them on in a bit. That's pretty cool. Yeah, see, I got the headlight off because I want to run this, and because the headlight only comes on when you run it, and I just want to make sure that I got the headlight working properly before I button that up. And then, oh yeah, I was going to show you, I got so if I turn this switch on, the tail light comes on, you see? So I'm just flicking it on and off. So that's the tail light, and then here's the brake light, right? And the same with the foot pedal. So yeah, so tail light, brake light works. And then if you turn, I don't know if you can see my hand and the switch or the light at the same time. So that turns all that off and on. So if you look here, see how the backlight is coming on? Yeah, so that switch controls all of that, and the headlight. It's kind of cool. You can go into dark mode when you're out riding around. Okay, so turn the key off. So we've kind of gone through that portion. So I fixed up quite a bit off camera, getting all this rigged up and looking pretty good. Not sure if my tachometer and speedometer drive cables are working, but I'll find out soon enough. Okay, and then next I'm just going to kind of run you through how some of this wiring is routed and kind of simplify or explain how it works. Okay, I'm going to try to explain how some of this wiring is routed now. So yeah, I got the battery disconnected, so don't worry guys, I'm not going to short out. Definitely going to be putting the proper cover back on here, and I'll be putting that away eventually. So positive right here hooks onto here. It splits off into two ways. One way goes directly to the rectifier, which would be the charging wire back to the battery, and then this wire goes straight to this fuse, and then on the other side of this fuse goes all the way over to the ignition key, right? So I'll come around that side. Okay, so red wire comes into the back of the key, and then when you turn the key on, it connects it to the black wire. So remember guys, on these bikes, green is ground and black is something else. It's positive. On this bike it's a switched on positive, so don't mix that up. Only the green wires on this particular bike and others, but black doesn't always mean negative on this stuff. Okay, so green is negative on these. So when you switch this on, power comes through and now goes out the black wire, and then it starts going up into all this stuff up here. So it comes out. I haven't figured out how this regulator is worked into the system. It doesn't show it on my wiring thing, but it does have a black wire going into it, right? So this is kind of like a junction right here. Let me dig it out for you. So these black wires, so this, when you turn the ignition on, you get positive coming up to here. It splits off, it goes into the voltage regulator, and then it also goes up this loom and up into, let's see here, it goes up into the brake switch up here for the front brake, and then another portion of it, which is right here, yeah, you also got a black wire. So this black wire comes up, and this is also switched on when you turn the key on, and it goes up into this loom, which goes up to this magic switch that I was talking about earlier. And so black wire comes in, and when you switch this on, it connects to the brown wire with the white stripe, and then that sends power to all your backlighting, tail light, all that stuff that you want to switch on when you turn this. So it goes in it comes into here as a black wire positive and comes out as a brown and white positive, and then works its way down here, turns the corner, and then there's a bunch of stuff that comes out of this plug here and goes back into the headlight, where this is where all the action happens, up and behind the headlight. We'll get to that in a bit. So black wire is positive, starts going into all this stuff, goes into your brake light switch, goes into this on off switch. So moving on, so also goes up into this. So so as far as the headlight, so this wire here, this is a white wire with a yellow stripe. Now this one comes directly out of the stator, and it comes out of this stator. There's a plug right here where it comes up, goes up through the frame, in through the loom, comes out here, goes directly into this switch, which is the other half of this on-off switch. Remember I was saying earlier that half of it's DC and half of it's AC, but when you switch it, one function does two different things. So you're switching AC and DC for different circuits. And I hope I explained that right. So it comes in, so this one, this white with the yellow comes into the switch, and then it comes out as this blue wire with the white stripe. Okay, so the blue and the white stripe goes in, and it comes here. It's joined right here, goes back into this little piece of loom, which goes up to the high and low switch here. So blue with the white stripe is AC power coming in, and then you got two options. You got your low beam and high beam. So low beam is the white wire coming out, and high beam is the solid blue wire. Yeah. Okay. And then so either the white and the blue come back out here, and you'll see them right here. So here's the white one, that's low beam, and then you got your solid blue right here, that's high beam. So remember, blue with the white stripe is AC power going up to the switch, and then you can select it high or low. Comes out either blue or white. Okay, and then so both those blue and whites, like here's the blue, here's the white, comes into the loom, turns a corner, comes out this plug, and goes back up under the headlight. Hey guys, I'm just going to jump in here and stop the video, and this next little portion I don't think is entirely accurate, and I'm going to let it play out, and then I'm going to jump back in and explain away what I think is the correct way of doing this. It just goes to show sometimes when you don't get to see how things come apart, how, you know, confusing it can be, and so on. So this next little portion I don't think is entirely accurate, but I'll jump back in and correct it. Okay, where you can hook it up here. So here's high beam, and then here's your low beam white wire, and then part of this low beam, there's a resistor that's part of the low beam circuit. It's tucked away back here, and it's got a white wire. It's hard to see, it's covered in black loom anyways, but it's right there. It comes into this, so that's this wire here. So this is the resistor, the one I got my finger on, and this one is the low beam coming out of this switch here. Right, so this is AC power going to the headlight for low beam, and then if I switch it to high beam, it now moves it over to this blue wire, which is high beam. High beam does not have the resistor, so I think that makes it, like, you know, more power. I think going off the top of my head, I think the white wire has 25 watt AC, and then the blue wire would be 35 watt AC at 6 volt or whatever volts. I think it probably varies depending on the RPM. And then so this green wire here, this is something I made up myself because I just needed a wire because I had to fix all this up. And this new headlight, oh I remember this. So see how this is like a double plug? This headlight I got this should have had a double plug here, so I had to kind of like rig up my own wire, because you need this one blue wire go up to this high beam indicator, So when you switch it to high beam, AC power comes down, and then it'll run this this as well as the headlight. And then when you switch it back to low beam, this goes off, and then you got your low beam working. So I hope that makes sense. And then, so I also discovered here, I was wondering what all this wiring was, and you might be too, right? So remember, here's your white wire. This is the low beam, and then you got your blue here is going into the headlight, which is feeding your headlight. This is also tied into that low beam, and then it just kind of comes here. There's a connector, goes up to the pink wire. And when I was fooling around in here, I was like, I didn't find, all this stuff is color coded, so you can just kind of connect the colors for the most part. But then I came across, I didn't have anywhere to put this pink. It didn't really belong anywhere, and I think this is just maybe for an accessory light. So I think if you wanted to run another AC light somewhere in here, you could plug it into here. They just put that in the loom. Maybe it's a loom that fits all different models, and in this particular instance it's not being used. Sometimes you see that where they leave it in there, but maybe the model below or above uses that wire, but in this case not. So this doesn't really need to be connected. I could it'd probably work fine like that, but there's no reason. We'll just, sorry, it's hard to do this with two hands or one hand. So I'll just leave that connected like it was, and this goes back onto here. I was just checking stuff out. Okay, now I'm going to jump back in and show you how I think this is more how it should be wired up here as far as the headlight goes here. So this is what I had going on before. I put the low beam white wires into this red one, and I had this wire made up for the high beam, and it's coming in here, and then it splits off so it can run the light and then run this this indicator bulb up here. And after reviewing the footage that I made, that I was editing, and I was wondering what this wire was for, because it didn't really have a purpose. It's the same plug as this other white wire. They're both connected together. It comes out here, and then it goes into this pink one, and then the pink one comes up here. And I was thinking about it. I'm like, why is that? And then of course when I got this bulb, this is like a replica, or a modern version of an old item. So it didn't come, it was like, I got it on eBay, and it didn't come with a wiring diagram with what goes to what. I didn't see how this came off, but it only came with, the one double spot, and this portion only had the one. And I was like, well, it must go to this, because I know that this this resistor wire needs to be part of the low beam circuit. But then after seeing this, I was thinking, well, maybe this pink wire is for the resistor, right? So what I think the correct way of wiring this up is actually putting the resistor on this pink one, wiring this low beam to this blue one, and then this one can go for the high beam, and because it's got two. And I was like, well, I don't know, right? Because what if I don't know which portion of the bulb this runs. And after looking at the bulb, like, I took the bulb out, and it's a 6 volt 35 watt by 35 watt. That means both filaments are 35 watt. And if you look at it closely, they're both the same. Like, there's no difference between the two. Like, I don't think it really matters which one is your high beam. They're both just as bright as each other, and I think the only difference is the low beam will have this resistor which will cut the wattage down, which will make it seem dimmer. And I think so in that case, what I think would work, I can probably get rid of this green wire and just use this one for the high beam, because it's got two, because I need two. I can put the resistor into this pink wire and then just run this white wire into this blue, because it doesn't really matter. And this black wire is ground. That was the easy part to figure out, was the black wire, because it, you know, it goes to the base. So I'm gonna, you know, rewire this the way I think would be better and simpler, and then it'll do away with this green wire that I made up. Okay, I'm gonna unplug all this. So what I was talking about, so I don't need this green wire. So I think the way to hook this up properly, so this is the wire that's going to that resistor. I'm going to plug it into the pink wire here, like so. And then this blue wire will now be my low beam, because it's a single. So plug that into there. And then this red wire with the double will run the high beam indicator, and then here's the power coming in for the high beam right here, like so. And I think that's a better way of doing it, and it makes more sense to me. And like I say, I didn't see how this came apart. This was all smashed, and so there's no, and these color, like this replacement light bulb or light, it doesn't have a wiring diagram. And after further looking at the bulb and stuff, it seemed like it didn't really matter which one of these wires was high beam. It just mattered which one had the resistor. And yeah, so I think that's what that wire down here is for. This is going to be for, and the reason why, so after also, another reason why I came to this conclusion, see this plug just plugs into here. And I went on to some forums to find out where this thing actually went, because it wasn't actually on here when I was putting this all back together. Like, I don't know where this went. And I was asking questions, and a lot of people said it was mounted down here somewhere, but there was nowhere to mount it. And the wire was only about, you know, maybe 8 inches long. So it had to go up somewhere up in here, just judging by how long the wire was. And then, so there was a guy on there that said, oh yeah, no, it goes right here, up here. And then some guys were saying it goes down here. And I think maybe different years or different times of the year, they changed the location of this. I'm not sure why that would be, but it would make sense that this wire here is down here, because maybe if that resistor was mounted here somewhere, this wire would just go to it right here. But in some models, if it's up on here, it makes sense that you'd have this wire and this harness go up to the headlight and plug it in the back here. And I think that's what is going on here. Because if you, I'll go over and I'll show you the wiring diagram. The thing about these wiring diagrams here, the thing about these, do I got it upside down? Yeah. So the thing about these wiring diagrams, it'll show you the resistor is in the circuit, but it doesn't show you where it goes and how far down the circuit it goes. Like, it's just a map of what's in each circuit. And there's some stuff that's missing on here. Like, I looked around, there's nowhere on here it shows you the voltage regulator. It shows you the rectifier, but there's no voltage regulator on here anywhere in this diagram. It also doesn't show that on-off switch for the headlights and the taillights and everything, to turn them on and turn them off. It doesn't show it in this diagram. And, you know, it's, I kind of had to, like, think about that one and figure it out. So, you know, these diagrams are good for mapping out circuits and stuff, but they don't show you how far down the line a junction or a join would be, or anything like that. So you kind of have to, you know, think about it and you know, see what makes sense. I don't know. It's it can be tough sometimes, right? So anyways, I just wanted to jump in there and correct that portion of the video. And I think the way I got it now, the way it hooks up, is probably better. I don't have to have that extra wire here that I made. So that's the way it goes sometimes. But anyways, back to the video. Here's your 6-volt flasher for the signal lights. This here is the 6-volt voltage regulator right here. Later on, they combined the rectifier and the voltage regulator into one unit. These older bikes, they seem to be separated. Not sure when that change was made. This signal light flasher tucks away in here. The new one I'm getting that I ordered is round. It's a 6-volt flasher, same wattage. It's I think it's a 18 to 23 watt. The one I got. The bulbs that are in the system are 21 watt 6 volts, so it should work with this system. It has a different hanger. This hanger's no, we don't need that anymore. And yeah. Okay, so what else? Oh yeah, I was going to talk about. So another thing that this switch does, it also has the so out of the stator, you've got a white, no, sorry, you've got a black with a white stripe wire. That's your wire for the ignition, for the spark and everything. And you've got your phase wires that go up to the charging system, and you got your one wire. One of those phase wires goes up and actually runs your headlight. And then in here, when I was playing around with this, there was a, I don't know if I can see it in here. There was an extra, oh yeah, here it is. There's this extra, you guys might come across this. There's like an extra black wire with a white stripe right here. And you might be wondering, what does that go to? And I think what this is for, it doesn't go to anything, but I think what it's for is, you could rig up another kill switch of some sort, if so need be. Like if you wanted to put some kind of fall off your bike safety switch, or maybe wire one to the kickstand, or something along that lines. It's like an extra spot because it's wired right into the black with the white stripe wire, which is your ignition wire. So anytime you ground that wire out, the ignition will cut out, which is what happens in the back here. So you got your black with the white stripe coming out of here, comes right up here, comes into the back of here, and you also got a green wire that comes up into the back of here. So when you turn this off, I assume that you're grounding that that black and white wire. As soon as you turn it off, it grounds it out. So anytime you ground out that black with the white stripe, it cuts the power to the engine. Right? That's what happens up here. That same black wire with the white stripe comes up into this switch, and then there's a green wire that comes up, and so either way you turn this, it just sends that straight to ground and cuts the motor. See, here's your ignition wire right here. This is the one I've been talking about. It's black. It's black with the white stripe. This is your ignition. So anytime you ground this wire out, it'll cut the motor out, which is what I think. If you were to take a wire, I'm going to test it out actually just to see if my theory is correct. But I think if I plug a wire into that one and hit it to the frame, it'll cut the motor out. So here it is again here. So you got your black with the white stripe. and it goes up, goes all the way up into here, like I was talking about. And then there's a green wire up in here, and then when you stick that, it grounds it out. And that's that. And then as far as under here, so a lot of these bikes, most, I would, 90% of them, I mean, the newer ones are starting to put a lot of the wiring underneath the fairing and stuff. But the headlight bucket is a real convenient place to have all these wires come out, and then you can make all your connection, and they kind of tuck away in there nicely. And at first glance, you kind of go, oh wow, this is it's pretty confusing. But it's not too bad when you can just pull them out, straighten them all out, so you can look at them. And a lot of these are just color coded. You got one that'll have multi points of being able to plug, so there's brown with the white stripe, and there's other ones that are brown with the white stripe, and you just plug into that. And you got your green wires. So these green wires, they're all grounds, every one of them. So you need to send a ground up to this bracket for your signal lights to work. You got one on each side. So you got ground coming up to the headlight bracket here, which makes this whole housing become negative or ground. And then so all you have going down the center on the inside is one positive wire, which is I think on this side it's the orange wire. And typically, I hope I get this right, I think typically the orange is the left and the blue is the right, I think, on this. So yeah, you just connect all, and then some of these wires come up here, make a connection for the front signal lights, and then you connect the orange wire, and it goes all the way down and down out to the rear signal lights, right? And so you come back here, and then you'll see you got an orange, so that would be your left signal. And then this one, it's hard to see because it's kind of dirty, but this one here, it's blue. It's a light blue. It's kind of faded because it's 50 years old, but that's your what did I say, right side? Let me just check here. Yeah, I think I got that right. It's either right or left. I think this is your right side, and then your left side, and then you'll have a ground wire. So you got two wires here. One of them is going to be ground, and the reason why they have to send a ground wire is because these brackets are rubber mounted, and you don't have a solid ground when you bolt through here, so they actually have to send a wire to the back of this bracket. They got it on both sides too, so each bracket is grounded. Same with up here. It's just a ground wire. It's just ensuring that you have proper ground. The same thing happens with a lot of bikes with these handlebars, because they're these are rubber mounted, a lot of them, and you can't count on, because basically your ground's going through the frame, going up through these bearings into here. That's not a very good way to ground your bike, because this is always in motion. There's grease and stuff in here, and dirt, and then you got to contend with all this rubber mounting and stuff. So you just send a ground wire up to these parts, just to ensure that you have proper ground. So that's why you'll have two wires here. I mean, you could probably test continuity on here, take that wire off and just test that. It would probably have ground, but it might rattle. It might not be stable enough for it to work properly. And yeah, I hope I covered a lot of that. It made sense, because like I say, I'm not an expert. This is in layman's terms, because let's face it, it's not rocket science. It's just trying to make it work, right? Trying to figure it out, and it takes a little bit of figuring out, but I think I got it. Yeah, if you have any questions, let me know. Leave a comment down below, and I'd love to get back to you. I hope you enjoyed this video, and I hope it helped solve some of your wiring woes. And if you like this video, please like and subscribe. It really helps my channel out. And stay tuned for more videos on this bike. It's going to be finished up here pretty soon. I should have it ready to ride on the road the next video or two. So I want to thank you for watching, and hope to see you again real soon. Center Stand Mechanics out.